Lesson 26, Types and Classes of Waves. Waves is a new category that we are going to be taking a look at in physics. So much like mechanics was its own category, and electricity, we now have waves. As such, there's going to be a lot of new vocabulary. Our objectives are first to be able to define waves so we know what we're talking about. The next two objectives are going to be using some of that new other vocabulary. You'll want to be able to evaluate the type of a wave based upon the medium through which it propagates. Medium and propagates being two new vocab terms. You will also want to be able to evaluate the class of a wave based upon how it propagates. So before we actually talk about waves, if we go back and think about what we know about energy, in your study of energy, whenever energy was transferred, or whenever we saw energy, there was some sort of movement involved. Matter was being moved. Waves are a method of transferring energy without actually transferring matter. What that means is this. If you think of the Bill Nye episode that you watched, there was a device that he had with a ball on one end, and he tapped the other end, and a wave traveled through the device and knocked the ball off the other end. He was able to knock the ball off the other end without actually touching the ball. He did not have to move his hand or transfer matter in order to transfer that energy. The energy itself was transmitted through the device. So even though the device itself vibrated, it didn't physically move from one place to another. And that's what a wave is, transferring energy without physically transferring matter from one place to another. Now, in order for waves to be transferred through something, they need something. That something is called a medium. So all waves must be carried by a medium. In the case of the Bill Nye example, the medium was the device. In the case of something more everyday, sound waves that we hear travel through air. So the medium for our sound waves is air. Now, I've been using the word traveling, but it's much better to say that waves propagate through a medium. That's the proper terminology. So sound waves propagate through the medium of air. And all waves are also caused by some sort of vibration or repeated disturbance. If you were to touch your throat while you're talking, you can feel your vocal cords vibrate. Every wave, regardless of what kind of wave it is produced by something which is vibrating. These terms on this slide will pertain to all types of waves. Now we can break waves up into two types based upon the medium through which they travel. The first type are called mechanical waves. Mechanical waves are waves that need a physical medium to propagate. By physical medium, we mean one that you can touch, like air or water, something physical. So sound waves are an example of mechanical waves, because sound for us needs air to travel. If we were a dolphin or a whale, our sound waves would travel through water. In that case, it's still a physical medium, water, that the sound waves are propagating through. Another example would be if you were lucky enough to be an astronaut on the moon, but you saw an explosion, you wouldn't hear that explosion because on the moon there's no air. There's nothing for that mechanical wave to propagate through in order to get to you. The second type of wave is called an electromagnetic wave. And electromagnetic waves do not need a physical medium to propagate. They actually create an electromagnetic field through which they could propagate. So in essence, it's like they're creating their own medium. Like all other waves, they're also caused by vibrations. In this case, they're vibrations of electrons in atoms. And because they are creating an electromagnetic field through which they can travel or propagate, they can travel through space or a vacuum, a place where there's nothing. So if you were that astronaut, you could see that explosion because light is an electromagnetic wave, but sound is a mechanical wave, so you wouldn't be able to hear anything. We can also classify waves into three types based upon how they travel. The first classification is called a transverse wave. In a transverse wave, if we look at the animation, we could see that the springs are vibrating up and down while the wave is traveling from left to right. A transverse wave is one in which the vibrations are perpendicular to the propagation. So looking at the picture, we can see that the vibrations are up and down while the movement is left to right, perpendicular. If you want to draw a transverse wave looks like what we have down at the bottom of the screen. Notice that it has an upward part and a downward part. The upward part is what we refer to as a crest. The downward part is what we refer to as a trough. These are the terms that we just discussed on the previous slide. The second classification of wave is called a longitudinal wave. And in a longitudinal wave, notice that the vibrations are right and left, and the propagation is also from left to right. So a longitudinal wave is one where the vibrations are parallel to the propagation. Now notice that there are places where the particles get compressed together, and other places where the particles get spread apart. The part where the particles get compressed together is called, logically, a compression. The part where everything gets spread apart gets a little bit more complicated name. A word that means to spread out is the word rarefy. So this part where the particles get spread apart is referred to as a rarefaction. In the picture at the bottom, the dark spots represent the compression, or where everything is compressed together, and the light spots represent the rarefaction, or the part where everything is spread apart. These are the terms that we discussed on the previous slide. Now, you may have noticed that longitudinal waves are kind of hard to draw, and they're also kind of hard for us to analyze as humans. Something else that you may have noticed was when you were watching Bill Nye had a segment where he was speaking into a microphone. Sound waves are longitudinal waves, so they look like the top wave in this picture. But what you saw was a transverse wave on the oscilloscope, what you see on the bottom part of this picture. What the oscilloscope did was it translated the longitudinal wave into a transverse wave so that it was easier for us as humans to analyze. The way that it does this, and the way that we will do this, is that every place that you have a compression is represented as a crest in a transverse wave. And every place that you have a rarefaction in the longitudinal wave becomes a trough in the transverse wave. Notice that they line up perfectly, crests with compressions and troughs with rarefactions. When you do your classwork for this lesson, this is what you will be doing. You will be given a series of longitudinal waves. You will want to line up the transverse wave underneath and draw it accordingly. The last classification of wave is called a combination wave. And in a combination wave, it's exactly that, a combination of both transverse and longitudinal waves. So the particles are not only vibrating perpendicularly, they're also vibrating parallelly to the propagation. This makes the particles move in a circle, and you can notice the circles moving in the animation. Now, something else that you may notice in the animation is that this looks like a wave that you're probably already familiar with, a water wave, because a water wave is a combination wave. Something else that you'll notice is that the particles that are vibrating are closer to the top or the surface of the water, and the further down you go, the less vibrations occur until you have no movement at all. This is because surface waves, or waves that occur on the surface between two media, in this case between water and air, are always going to be combination waves. So combination waves are waves that have properties of both transverse and longitudinal waves. The combination makes the particles move in a circle. All surface waves, or waves that occur on the surface between two media, are going to be combination waves.